Hello everyone, my name is Rakshita Joshi. Our group number 8, including me and my fellow mates Sachin Rawat and Priyanshu Kaneri, are going to present the topic polydienes, in which we are going to talk about properties of polydienes and the applications of polydienes. In properties, we will talk about physical and flow properties and thermal and mechanical properties. So let's begin with the introduction. Polydienes are usually a class of synthetic polymers that are made up of diene monomer. From diene, we can understand that di means two and ene indicates the double bond. So monomer that contain two double bonds. Now let's talk about physical properties of polydienes. Firstly, if we talk about transparency, polydienes like polybutadiene and polyisoprene are often transparent or they have good optical clarity. Polydienes have low density uh, that is vary depending on their composition and their structure, and due to low density they are lightweight and which is useful for production of so many articles. The melting point of polydienes are usually low. That is also depends on their composition and their structure. If we talk about solubility, some polydienes are soluble in certain solvents, but some are not. This property can be tailored through the copolymerization or modification. Polydienes are not good conductor of electricity. They have low thermal conductivity and which is advantageous in some applications. Polydienes are good electrical insulators. Now let's talk about the flow properties of polydienes. The flow viscosity of polydienes depends on their molecular weight. Higher the molecular weight, higher the viscosity of the polydienes. And the flow viscosity also depends on the temperature. Higher the temperature, lower the viscosity of polydienes. So we can say the viscosity of polydienes is directly proportional to molecular weight and inversely proportional to temperature. The flow properties of polydienes, like other polymers, are influenced by the several factors. Firstly, molecular weight. As we have talked about that higher the molecular weight, higher the flow viscosity of polydienes. Second, the temperature. Higher the temperature, the lower the flow viscosity of polydienes. And polymer structure. Higher the bulkiness in the polymer, lower the high higher the bulkiness in the polymer, higher the viscosity of polymer. As these, there are some OR factors, that is cross-linking additives and processing conditions in which flow property depends. Thank you. I would like to call Priyanshu Kaneri for further explanation.
Thank you, Rakshita. Hello everyone, my name is Priyanshu Kaneri and the topic of my presentation is thermal properties of polydiene. And firstly, I would like to inform you what does thermal property actually mean. Thermal property of any material refers to its ability to conduct, transfer or resist heat. So here are some major thermal properties of polydiene. First is glass transition temperature. Certainly, glass transition temperature is like a point where a material changes from being hard and brittle to becoming softer and more flexible. Polydienes have relatively low glass transition temperature, typically below room temperature, and this is the reason why most of the polydienes are flexible and rubbery at common temperature. Second property is heat resistance. Polydiene materials have good heat resistance. They can withstand moderately high temperature without significant degradation. The reason behind their high resistance is their molecular structure. They consist of long chains with repeating diene units, which provide them flexibility, and also ability of these chains to form crystalline structures contribute to their heat resistance by limiting molecular movement. The third property is thermal conductivity. Polydiene materials typically have low thermal conductivity. They are poor conductors of heat, making them useful as insulating materials. They have low thermal conductivity because their molecular structures includes long chains with weak intermolecular forces hindering efficient heat transfer. The fourth property is melting point. Polydiene materials have low melting point, typically below 100 degrees Celsius. These characteristics make them suitable for processes that involve low temperature melting, and the reason behind their low melting point is also weak intermolecular forces binding them. Along these properties, they also have properties like chemical resistance, which provide durability to material. Viscosity and solubility are also some properties of polydiene. Now I would like to hand over the topic to my friend Sachin Raut, who will be sharing some valuable insights. Thank you.
Thank you, Priyanshu Kaneri. Good evening, ma'am. I'm here to explain my topic, that is mechanical properties of polydienes and the application of polydienes. Before explaining my topic, I would like to thank my classmates Priyanshu Kaneri and Rakshita Joshi for making this presentation. Now moving on to the topic, that is mechanical properties. So it possesses various key mechanical properties such as elasticity. Polydienes are highly elastic, allowing them to return to their original shape after deformation. This is due to the presence of double bonds in their polymer chains. The repeating units in polydienes contain carbon-carbon double bond, which introduce a degree of flexibility into the polymer structure. This flexibility allows the polymer chains to easily slide past each other when subjected to stress and return to their original positions when the stress is released. Additionally, the double bonds can undergo a form of chemical cross-linking known as vulcanization. During vulcanization, the sulfur bridges form between adjacent polymer chains, creating a 3D network. This cross-linking enhances the elasticity, strength, and overall mechanical properties of polydienes. The second point is the elongation at break. These polymers can stretch significantly before breaking, indicating their high elongation at break. There are several sub-factors including in this point. First is polymer chain entanglement. Polydienes exhibit a degree of polymer chain entanglement due to their flexible molecular structure. This entanglement allows the chain to resist separation under stress, contributing to elongation before breakage. Cis-transisomerism. In the case of polybutadiene, for example, the presence of cis and trans isomer in the polymer chain influences its mechanical properties. The cis isomer contributes to greater chain entanglement and higher elongation at break as compared to the trans isomer, and the also the extent of cross linking achieved through vulcanization plays a crucial role, as this well crossed link structure enhances both strength and flexibility, allowing the metal to stretch more before breaking. So in essence, the elongation at break in polydienes is an interplay of molecular factors, isomerism, cross-linking, all shaping the material's ability to undergo a significant deformation before rupture. Now, the third one is abrasion resistance. Their rubbery nature provides resistance to abrasion, making them suitable for applications involving wear and tear. This is possible due to some reasons. First is flexibility. The flexible and amorphous nature of polydienes allows them to absorb and dissipate energy, reducing the impact of abrasive forces. This flexibility helps the polymer withstand wear and abrasion without breaking. And high elasticity. The elastic properties of polydienes contribute to their ability to deform under stress and then return to their original shape. This property helps them to resist wear and tear, as they can absorb and recover from mechanical stress. In summary, the combination of flexibility, elasticity, and vulcanization makes polydienes well suited for the application where resistance to abrasion is crucial. These specific mechanical properties can vary depending on the specific type of polydiene, its molecular weight, and the additives used in its formulation. Now moving on to my second topic, that is applications of polydienes. That is, as it is well written, the polydiene is largely used in various parts of automobile tires. The manufacturing of tire consumes about 70% of the world production of polybutadiene, with the majority of it being high cis because of their excellent wear resistance and low rolling resistance. About 25% of the produced polybutadiene is used to improve the mechanical properties of plastics. The most golf balls are made up of an elastic core of polybutadiene surrounded by a layer of harder material. Polydiene rubbers are commonly compounded with carbon black in making wide variety of rubber articles including horses, belts, surgical gloves, etc. Polydiene is also used as a binder in combination with an oxidizer and a fuel in various solid rocket boosters such as Japan's H-2B launched vehicles and European Space Agency Ariane 5. Apart from that, it has some various applications like I would like to add it a modified asphalt. Polydines are added to asphalt formulations to enhance the durability, elasticity, and resistance to temperature variations. So that is it from our group, and thank you.